Hello everyone, welcome to Equal To, and this is the fourth video of our first playlist, which is Matter in Our Surroundings, which is Class 9 Science. Right, if you haven't seen the previous 3 videos, please go and check them out. Now in this video, we are moving on, and previously we discussed the in-text questions, right? Now we are moving with the next topic, that is states of matter. Now we have a simple image here, right? And I have marked 3 things there, 1, 2 and 3, and you could see that option number 1 or marking number 1 is a lamp, right? And a lamp is obviously solid in nature. And option number 2, marking number 2, we have a bottle of water, and that water is actually liquid, right? And 3, I have just marked the empty space in the room, which obviously represents air, which is gas, right? Air is just a mixture of gases, right? So you could see the variation in characteristics of particles of matter, right? It can either be solid, liquid or gas, and that is what exactly we are going to see in this video. Let us start with solids, right? The solid state. On your left, you can see certain examples. You have a pen, you have books, you have needle, you have a block of wood, right? What are the things that are common in all these things? They definitely have a definite shape. It doesn't change, right? If you have a pen, no matter wherever you keep it or how long it takes, the shape of the pen remains the same, right? So it has a definite shape, and that applies for a needle, for a wood block, a book, everything, right? It has definite shape and has distinct boundaries. So what exactly do we mean by distinct boundaries? If you keep a pen in the table, no matter how many hours it takes or whatever happens, the volume of the pen or the space that it occupies is not going to increase or decrease, right? That is the boundaries of this pen. Like you can place this pen somewhere and you can trace the outline, and the outline is going to be there. The outline of this pen will remain true because the shape of pen will not change. Its boundaries are intact and it will not change, and the boundaries are distinct, right? And if in case of water, if you pour a few drops of water, it will start flowing. It will not have boundaries, right? And that is not the case with solid state, and that is what they are trying to tell here, right? It has distinct boundaries and fixed volumes, right? Fixed volumes, obviously the shape is not going to change and the size is not going to change. It is not going to expand or compress or anything. So it has fixed volumes. So what does this 3 things mean? It has negligible compressibility, right? It is not possible for you to compress this block of wood or these books, right? You cannot compress it just by applying force. You cannot compress it, right? So negligible compressibility, meaning little to no compressibility is present in solids, okay? Solids of matter. Now again you could come up with a few more observations, right? They have a tendency to maintain its shape, right? These are just adding on those points, right? It may be repeating, but this is just adding on that points. The solid state, they have tendency to maintain its shape, right? They don't want to change shape easily. Like it's not water, it's not air, right? They tend to maintain their shape. They may break under force. So maybe you try bending a pen, you'll not be able to bend it, you'll not be able to reform it. Instead, if you apply enough force, you'll be able to break the pen. So it breaks under force and it doesn't reform, right? And it's difficult to change its shape, right? That like everything adds up, right? It's you will be able to break it if you apply enough force, and you will not be able to reshape it, and they have a tendency to remain in the same shape, like maintain its shape, right? These are the characteristics of solid state, and what we are telling is that solid state has negligible compressibility, and solid states, the solids are rigid, right? They are hard and they have negligible compressibility. These are 2 observations. Now you may come up with this question, right? You have a rubber band, and when you apply force on it, if you stretch it, it reforms. So is it a solid? This is one question. And the other one is, you have salt or sugar, right? Based on the based on the vessel that you put it in, based on the container that you put it in, it reforms, right? It takes the shape of the container. Is it so? So is it solid? So isn't salt solid? And the other one is sponge. You can compress a sponge easily. So all these things, they contradict with the facts that we just saw about the solid state. So aren't these things solid? That is the question. Now coming to the rubber band changes its shape only when you apply force on it. When you apply force on it, it changes its shape, right? But once you remove the force that you are applying, the excessive force, it regains to its position. So it has the tendency to maintain its shape, right? And if you apply if you apply excessive pressure, excessive force, it will break. The rubber band would break. So it is a solid. Now coming to salt, we are collectively saying that the salt is taking the shape of the container. But if you take an individual crystal of the salt, if you take an individual crystal of sugar, that shape is not going to change, right? It's not going to change. Only the only when you think collectively, it is occupying that space. But individual crystal, it is not going to change its shape. So it's solid. And coming to sponge has air holes in them, meaning air is trapped inside sponge, and when you try to apply force on it, the air is exhaled, right? The air comes out, and only because of that the shape of the sponge is changed. And when you release it, it gains the position back. It gains its shape again, right? So what does this tell you? It is changing shape because of the air trapped in it and not actually changing its original shape, right? So sponge is solid as well. And that is what we have about solid state. Moving on, we have the liquid state. Now before moving on to liquid state, what are the things that we have learned in solid state? Solids are rigid and they have negligible compressibility. Okay, they have a tendency to maintain their shape, and they have negligible compressibility. They are rigid. This is what we have learned about the solid state. Now moving on to the liquid state, you could see there is a milk carton there and it has milk in it, right? If you pour the milk in a glass, it takes the shape of the glass. So liquids take the shape of the container, okay? And since they can flow and change their shape, we call them fluids as well, right? The milk flows from the milk carton to the glass and takes the shape of the glass, right? So you can call it a fluid. It flows, so it's a fluid. Now another thing is, if you take 100 ml of water and pour it in a water bottle, it will still have the same 100 ml of water, meaning the volume is fixed, right? Earlier we saw that liquid takes the shape of the container it is kept in, but the volume of the liquid doesn't change. No matter what container you place it in, the volume remains the same, right? One more thing about liquid is that we tried putting salt into water and mixing it, and we also took KMNO4 solution, that is potassium permanganate solution. These are things that we have already seen. Okay, I hope you remember these things. If we take potassium permanganate solution and again mix it with water, it was able to mix easily, right? So diffusion was easily possible in liquid state, meaning that the particles of matter have more space in between them. Okay, so liquids diffuse easily in liquids and solids diffuse equally in liquids, right? That is what we have seen here. And moving on, one more thing about liquid state is that even gas can dissolve in liquid, right? We have O2 and CO2 in and some other gases in our air, right? Atmosphere, and these things dissolve in water, and that is how water has oxygen, dissolved oxygen in it, and that is how aquatic life breathes. Okay, so yeah, even air can diffuse into liquid. Solids, liquids and gases can diffuse into liquids. So we have seen solid diffusing into liquid with the salt experiment, liquid diffusing with liquid with potassium permanganate solution, and gas can diffuse into liquids that we have even in the sea, in the pond, anything. Air diffuses in the liquid, and that is how aquatic life is able to breathe. Particles move freely and have greater space between each other as compared to particles of the solid. Okay, so since the particles move easily between them, that is how it gets the fluidity nature, right? It's able to flow because the particles can move easily. But that is not the case with solid, so it's rigid. But fluids can flow, liquids can flow, right? Now we are coming to the third state of matter, and that is gas state, right? Now if we take 3 syringes, okay, the syringe, the one that we use in hospitals, right? You fill one with air, you fill one with water, you fill another one with chalk, okay, or any other solid. Now if you try compressing it, you'll be able to compress the gas a lot, you'll be able to compress the liquid very little if you apply so much pressure on it, and you'll not be able to compress the solids, right? So what inference does this give us? Gases are highly compressible when compared to solids and liquids. This is one thing that we get. And few examples of gases, we have LPG, right? Liquid petroleum gas that we use in our homes to cook. We have that, and that is compressed. That is compressed into liquid and stored in the cylinders. And that is how they store a lot of gas in some volume, very small amount of volume. And the oxygen cylinders that we use in our hospitals, right? They are also compressed oxygens. And we use CNG as fuel in our cars and auto rickshaws, right? CNG is compressed natural gas, and CNG has high compressibility, that a large amount of fuel can be compressed into very small volume, which can be easily transported, right? That is one advantage. And all this tells us that gases are highly compressible, right? And gases diffuse very fast. Okay, you are in your hall, you are watching TV, and someone is cooking in your kitchen, probably your mom, and you'll instantly get the smell of it, right? As she is cooking, you will be able to smell it. Why? Because hot sizzling food, we have already seen this, right? They have more kinetic energy, and that is how they reach us, right? And gases generally have high kinetic energy. The particles, they move very quick when compared to solids and liquids. They generally diffuse faster into other gases. Gases diffuse very fast into other gases, and when you increase the temperature, that even escalates. The kinetic energy is even more increased. Okay, that is what happens here. So what about gases? Gases have high compressibility, and they diffuse very fast into other gases. Okay, now overview, we are seeing solids of states of matter. In solid, you can see that the particles of matter are very closely packed. There is little to no space in between them, and these particles, they are not able to move. Okay, but in liquids, you have some space in between them, and it gives you some way of the particles move slowly, or they have some freedom to move around in liquids. And in gases, you can see there is absolutely a lot of space, so they move randomly, and they also hit each other, and also the walls. That is how the pressure of the gas is formed, right? So the particles in gases have they can move very freely. Okay, the motion of particles can be compared in the 3 states of matter. So this is how that we have compared the motion of particles in 3 states. Gases, the particles, they move rapidly, they can move very easily, there is no constraint there. In liquids, they can move to an extent, but in solids, the movement is very, very less. So I hope you have understood all the things that we have discussed. We have discussed the 3 states of matter: solid, liquid, and gas. Solid, they are rigid, they have negligible compressibility, and they maintain their shape. Liquids, they can diffuse into like solids, liquid, and gases. All these 3 things diffuse into liquids easily, and they are also called fluids because they flow, okay, and they take the shape of the container that they are held in. And coming to gases diffuse into gases very fastly, and gases are highly compressible in nature. So that is all that we have seen in this video. If you have any doubts or questions, please let me know in the comments and I'll get back to you as soon as possible. And please let me know your suggestions as well. See you in the next video. Bye for now.